What's up, math scholars? It's Mrs. Harp here. We're going to learn about 1.5 day 1 today. Rationalize. So it's a pretty exciting day for you. Who's excited? Woo! I'm alone in the classroom again. But hey, I hope you're excited at home watching this video. All right, just a couple vocab words to start the day. Go ahead and write this down in your notebook. Square root. The square root of a number is a value that when multiplied by itself gives the number. So you've all done square roots since, who knows, middle school, right? So let's say we're taking the square root of 4. We're looking for the number, the value, that when multiplied by itself gives that number 4. So it's 2, because 2 times itself, 2 times 2, would be 4. Okay. Sometimes we also put a plus minus in front of our answer, because -2 times -2 would also be positive 4. But in general, unless we're solving for a variable x, we normally just write 2. So I think today we'll just have positive answers. We'll get into solving tomorrow. A radical is that actual symbol. Looks like a little jail, kind of. It's an expression that has a square root, cube root, etc. And then a radicand is the value on the inside. So let me show you. The green here is the radical, and the 4 itself is the radicand. Okay. All right, there are some properties. Go ahead and jot down the 2 properties I'm about to circle. We've got the product property. We can use this property both forwards and backwards. So you can split a radical into 2 numbers, 2 products, or you can take 2 numbers and put them together. Let me show you what I mean by that. If I had, for example, the square root of 2 times the square root of 50, since they're both square roots, I could put them all underneath one giant square root together, 2 times 50. And 2 by itself is not a perfect square, and 50 by itself is not a perfect square, but put them together, look what we get, the square root of 100, which is a perfect square, 10. So it's kind of cool that sometimes you can put them together and get that perfect square. The quotient property here on the bottom, go ahead and write down what I'm circling in green. So this is the same deal. Sometimes numbers together aren't perfect squares, but you put them together. By themselves, they're not perfect squares, but you put them together and they are. Okay, so the one I thought of would be radical 32 over radical 2. 32, can't really square root that easily. It's not a perfect square. Same thing with radical 2. But watch what happens if we put them together. Square root of 32 over 2 would be the square root of 16, and 16 is a perfect square, so you get a nice happy answer. That's how you can use the product and quotient rule to get nice happy answers. And they have examples there on the far right that you can look at as well. All right, let's go ahead and make a list of all the perfect squares from 0 to 100. A perfect square is a number that if you square root it, you get a nice happy integer solution. So like 1, for example, 4, 9. So the square root of 1 equals 1, the square root of 4 equals 2, the square root of 9 equals 3. They have nice happy integer whole number answers. 16. 25, 36, and this would keep going forever. You don't necessarily need to memorize all the perfect squares from 0 to 1,000 or anything, but I would definitely recognize the perfect squares from 1 to 100. So you recognize them and you know them and you can think of them quickly. Okay. So if you have a large number and you need to test if it is a perfect square, you would just type it in your calculator and square root it. So let's say I want to know if 1056 is a perfect square. I don't know if it's a perfect square or not. I don't have my perfect squares memorized from 0 to 5,000, you know. So just type in this calculator, square root of 1056, and see if you get a nice, happy, whole number answer or not. I typed it in. I got 32.496. It goes forever. It's called an irrational number. So no, it's not a perfect square. All right, so we are going to learn how to simplify radicals. Go ahead and jot our first example problem down, square root 20. Now, it is going to be our job to break all the factors out of that radical that we can. So all the perfect squares kind of have come out. Let me explain. The square root of 20, I can break down using the product rule into the product of these two radicals, square root 4 and square root 5. 4 times 5 is 20. Now you might be wondering, why did I choose 4 and 5 instead of 10 and 2? Well, 10 is not a perfect square, 2 is not a perfect square. So your job needs to be to break it into two factors such that your first factor is a perfect square. Because what we're going to do is take the square root of 4, which equals 2, and then just leave that square root of 5 as is, because the square root of 5 is an irrational solution. And then 2 radical 5 is what radical 20 would look like simplified down. It's called its simplified radical form. Now a great way to check yourself to make sure you didn't mess up is to grab your calculator. Type in the square root of 20, see what it is as a decimal, 4.47, and then type in 2 times the square root of 5 and just make sure it is still 4.47. If it's not, if these decimals don't match, you messed up something with your factoring and something with your simplifying, okay? So we don't need to write those 4.47s down. That was just a quick check to make sure we did everything okay. Let's try radical 18. Now, again, we want to break down 18 into a product of two factors, such that the first factor is a perfect square. Can you think of what number we should use? It's 9. 9 times 2 is 18. And then we take the square root of 9, which equals 3, and we leave the 2 in the radical. So 3 radical 2 is the simplified form of radical 18. Good job, guys. All right, I want you to pause the video and try these next two all by yourself, and then we'll check. Okay, did you try them by yourself? The 24, you would want to break it down into the square root of 4 times the square root of 6. So 2 radical 6 is your simplified form. The 50, you'd want to break down into radical 25 times radical 2, because square root of 25 is a perfect square. It gives you 5. So there's your two answers for those ones. All right, looks like a couple quotient rule problems to try. What I would do on this first one is just make the 4 and the 81 have separate radicals, because I noticed both of those numbers are perfect squares. The square root of 4 equals 2. The square root of 81 equals 9. And then that's my answer, 2/9. Over here on the right, part D, I could give 7 his own radical. I could give 16 his own radical, but the square root of 16 is the only perfect square in this situation. So our final answer will be radical 7 over 4. Ooh, we have a lot of these. How about you go ahead and try them by yourself? Pause the video, try them by yourself, and when you click play, all the answers will appear. Ta-da! Here's all the answers. Go ahead and check your work. Email me if you ever have any questions this year. It's kind of a challenge. Some of you are at home, some of you are at school. Those numbers might change as we go this year. Okay? All right, we finally get to learn the hardest concept of the day, rationalizing the denominator. At some point in math history, mathematicians decided they just did not like radicals in denominators when they are working with fractions. So there are techniques to rationalize and get those radicals out of the denominator. So rationalize the denominator means to eliminate the radical from the denominator. We're going to do that with the use of conjugates. It's very important for you guys to maybe take a picture of this slide or jot it down in your notebook, because this is the concept of how conjugates work and is a chart for techniques we will use to rationalize the denominator. You can pause the video and take a picture of that or jot it down. Okay. All right, let's try our first problem. We're going to start with number A. I would write it down as the radical 5 over radical 2. Now our denominator is of the form one single square root. If I take you back a slide, that would be this guy here, square root b. And if your denominator is in the form square root b, you will multiply your numerator and denominator by square root b. So what I'm going to do is I'm going to multiply my numerator and my denominator by square root 2. I'm not really changing the value of my original fraction. I'm multiplying by something that has the value of 1, because that's the same thing on the top and the bottom. But this is going to basically be a magic trick. You'll multiply straight across the top, you'll get square root 10. All right, on the bottom, this is what is so cool about our technique we're using. We multiply radical 2 times radical 2 and get radical 4. Hot dog, there's a perfect square. That's what we like to say in class when we do these problems. So on the top, it'll be radical 10. On the bottom, it'll be a 2. And we've been rationalized. What we started with in the original problem and what we ended with will have the same value if you check on the calculator. But what we ended with doesn't have a square root in the denominator. So it has been rationalized. Okay? Part B. This is going to be a little bit harder. If you look at our denominator, it's more than just a single radical. It's a number being added to a radical. So let's look at that chart. Number being added to a radical. We have this situation right now. So what we're going to use is a conjugate. A conjugate is an opposite. So what you'll do is you'll group your denominator because it is 2 terms. Then you'll place the opposite both here and here. You always have to do on the bottom what you do on the top. 7 minus radical 2. That's your setup. This is gonna get crazy. We have to distribute on the top, we have to FOIL on the bottom. There's a kind of a trick to foiling conjugates though, it's pretty neat. So distributing, we'll have 21 minus 3 radical 2. On the bottom, we're gonna do a full out FOIL. 7 times 7, 49. 7 times negative radical 2 is negative 7 radical 2. I always put the number first and the radical second. Then our inside would be a positive 7 radical 2. And then our last matchup would be a negative radical 4. So let me explain what's happening here. On the top, there's not much we can do. 21 minus 3 radical 2. On the bottom, these will go away. That always happens with conjugates. Your inners and outers always add up to 0. So we'll get to the point where we won't even FOIL those inners and outers. The square root of 4 becomes a 2, so it's just 49 minus 2, which is 47. And that's all we can really do on that one. It's a lot of work using those conjugates, but it always creates perfect squares and helps us rationalize our denominator. All right, another problem where we have a 2-term denominator. As soon as I see those 2 terms, I plop those parentheses around there because we are about to use some conjugates. Do you know what our conjugate would look like? Take a guess. It would be 4 minus radical 11. So on the top, we'll do our distributing. 8 minus 2 radical 11. And on the bottom, we're just going to do our first and our last matchup because as I explained on the previous slide, our outers and our inners would end up canceling anyways. 4 times 4 is 16. Positive radical 11 with negative radical 11 is negative radical 121. So what we've got now is 8 minus 2 radical 11 on top. And that becomes 11, so it looks like 16 minus 11 would be 5. And that's it. Oops. The board's kind of freezing. All right, we're back. My smartboard was freezing a little bit, and I'm going to make sure to give you a problem with 2 terms on the top and 2 terms on the bottom, because those are extra fun and challenging. And they separate the math scholars from the non-scholars. So do you want to be a scholar today? Yes, you do. Have I sung the scholar song to you guys yet? The best time to be a math scholar is all the time. Had a freshman make that song up last year. It's catchy. All right, so we're really only focused on the denominator. Our job is to rationalize that denominator. So we're going to go with a 6 minus radical 3 on top and a 6 minus radical 3 on bottom. And I just made this problem up about 5 minutes ago, so we'll see how it works out. Let's start on the bottom. I know that sounds crazy, but the bottom, these are conjugates, so I can just do my first with my last. 6 times 6 is 36. Positive radical 3 with negative radical 3 is negative radical 9. On the top, however, these are not conjugates. You'll have to do the whole entire FOIL process. First, 18. Outside, negative 3 radical 3. Inside, negative 6 radical 2. And last, positive radical 6. Now that's a flat out mess, but you know, we did accomplish our goal. We did rationalize the denominator because we created that perfect square right there. Square root 9 is 3, so my denominator is a 33. My numerator, I was looking at this, to be honest, there's not a ton we can do to clean it up. There's a little we can do to clean it up. This radical 6, nope, never mind. I cannot simplify that any because it's just 3 times 2. 3 and 2 are not perfect squares. So I think we just have to keep it all separate. 18 minus 3 radical 3 minus 6 radical 2 plus radical 6. They're not all going to be that messy. Sometimes you'll have things that can combine, but I don't think there's anything to combine there. Our radicals don't match, so we're done. Hey, thanks for tuning into the video today. I know rationalizing is a skill that you will use from now on in all the higher level math classes you take. It's not the most fun, but it is an important skill to learn. So I'm proud of you guys for learning it today. Have a good one.